What is the last thing we just did? Yeah. Okay, so sequences in series. A new thing. Come on, I know this is working. Okay. So a sequence is defined as an ordered list of numbers, right? These are examples of sequences, right? By ordered list, it means if I give you the numbers 2, 4, 6, 8, that's different than 8, 6, 4, 2 because the order is different, right? There is such a thing in that list of numbers as a first term, and a second term, and a third term. So that's why it is ordered. That's the ordered part of it. An ordered list of numbers. Now, a sequence can be infinite or it could be finite, right? Infinite means it goes on forever. It has infinitely many terms. And you recognize it by the dot, dot, dot at the end, right? That means that there's infinitely many terms in the sequence. Right? The finite, there is no dot, dot, dot at the end. That means there's only those 4 terms. Right? So infinite and finite. And that's how you say it. What's that? If it has the dots, it's infinite. If it doesn't have the dots, that means that's your sequence. It's just those 5 numbers right there. Infinite. Right? That's working. Okay. Okay, so individual terms in a sequence are represented by a lowercase letter a with a subscript. So when you say lowercase letter a with a subscript of 1, it means the first term in the sequence. Right? And this one here, the A1 is 2. And this one, A1 is 1. Right? In the third sequence, what is A4? It's the 4th term, right? 16, right? In the first sequence, what is A2? It's 4, right? It's the value that's in that place. We're going to get to that. They don't have to have a pattern. You could have a pattern. I mean, what if my sequence was the digits of pi, right? Well, pi by definition doesn't have a pattern. So, you would just see one number after another and there wouldn't be any relationship to the one that came before it. So sequences don't have to have a pattern. But we're doing a very particular lesson today, which is about 2 patterns, arithmetic and geometric. And that's all we're really responsible for here. We good? So a sub n, if I use a subscript of lowercase letter n, that refers to the nth term or any term in the sequence. So a sub n, for example, in this first one here, do you see a pattern? Do you see the pattern, right? It would have a formula for the an, which would be 2n, right? 2n is the a sub n, because I can use that to find any term in the sequence. right? If I plug in 4, that'll give me the fourth term, and it's 8. That's correct. What if I wanted to find some term that's not on there? It goes on forever. What if I wanted to find the 100th term? Then I would plug in 100. So the formula for AN is a formula that you can use to find any term in the sequence. And sometimes, if it has a pattern, then we'll be able to come up with an expression that represents that pattern. What does it look like the pattern is? What's going on here? It looks like you're doubling it. And the way you make a double is you do this. You go 2 to the n minus 1. Right? If I plug in 1, I should get the first term. N equals 1 will give me 2 to the 0. What's anything to the 0? 1. Okay, plug in n equals 2 for the second term. 2 to the 2 minus 1. That's 2 to the first, which is 2. Find the third term. 2 to the 3 minus 1. That's 2 squared, which is 4. So every term in the sequence, because n is 1 more, we get 1 more power of 2, 1 more factor of 2. So it's doubling. What's the pattern here? 1, 4, 9, 16, 25. Anybody recognize those numbers? Blank. They're perfect squares, right? Those are the perfect squares. So the formula for the nth term would be n squared, right? So formula. So an, they use the term, the nth term, to represent that. It just means it's a formula for any term in the sequence. As long as you know the n, the value of n, meaning the number of the term, the ordinal number of the term in the sequence, you plug in that value for n, you get the value that's in that place. What is, using this formula right here, if I wanted to know A10, the 10th term in the sequence, I would say A10 equals 10 squared is 100. Like that. So everything, all the slides up to this point had nothing to do with the arithmetic or geometric. They're just kind of general sequence stuff. I think after this we'll get to the geometric or arithmetic. We're good? Okay. So an arithmetic sequence is a particular sequence, and the definition of it is, the math definition of it is, it's a sequence in which the difference between consecutive terms is constant. In more common speak, it looks like you keep adding the same number to get the next term. That's arithmetic, right? If it looks like you keep adding the same number to get the next term, that's an arithmetic sequence. It is. If you subtract the third term minus the second term, the fifth term minus the fourth term, those are consecutive terms. It should always be the same. It should be equal to that number you keep adding. But that's what arithmetic is, and that's the way you're supposed to say it. It was just general. It was not any particular kind of sequence. It was just general information about sequences. Good, Deshaun? Okay. So which one of those looks like it's arithmetic? That you keep adding the same number to get the next term. what does it look like you keep adding? 2, right? So if you, and this is what we mean by the difference of consecutive terms, right? If I do 4 minus 2 is 2. If I do 6 minus 4, it's 2. If I do 8 minus 6, it's 2. So the difference between consecutive terms is constant. That's by definition what arithmetic is. Either one of these two look like they might be arithmetic? No. I mean, if you always check by going, do the subtraction for the first two terms. 2 minus 1, 1. Okay, do it for the second two terms. 4 minus 2, 2. Okay, it's not constant, so it's not. 4 minus 1, 3. 9 minus 4, 5. Okay, stop. Okay. So if it appears like you keep adding the same number to get the next term, whatever that constant difference is, it's called the common difference, right? The common difference. And we use lowercase letter d represents the common difference. Like in the last one we looked at, d was 2. Right? That was what we kept adding to the next, to get the next term. So in the sequence which is on the screen there, is that arithmetic? Okay, does it look like that? Okay, so you say 6 minus 3 is 3. 9 minus 6 is 3. 3. 3. So would you say it's arithmetic? Yeah. What is the common difference? 3. So you would say D equals 3. D equals 3. Common difference. It's too easy? Not that much harder. I mean, in the end, the thing about the sequence and series is everything we do with this stuff has got a formula, and you're given the formula. So you don't have to memorize any of that stuff. It's on the formula sheet for the SOL. Yeah. Well, if it's in this kind of question, is it arithmetic? You would say yes. And if it had a further question, which it almost always does, what is the common difference? D is 3. So this is your U try. For these two sequences, say whether it's arithmetic, and if it is, what is D? I'll come around and sign them, and you keep them. So if you want to keep them in a notebook or something, I'll sign them. There'll be plenty of time for that. So were they both arithmetic? Which one was? Which one was arithmetic? You know, in the first one, 4 minus 2 is 2. 8 minus 4 is 4. It's not a constant difference. So this is not. This is a 2. This is a 4. So not equal. So not arithmetic. Okay, if you said that the second one was arithmetic, what's the common difference? 4, right? It looks like you keep adding 4. 4, 4, 4, 4. So D equals 4. what if, because we don't have a lot of examples like this, but you probably will in the homework. What if that sequence instead was 17, 13, 9, 5, 1? Then what would be the common difference? It'd be -4. You know, what do you keep adding to get the next term? -4. So you could have the terms getting smaller and be arithmetic, right? -4, -4, -4, -4. Okay, next step. Right, there is a formula for the nth term of an arithmetic sequence. Right, it's right there. Right, a sub n, remember the a sub n means the nth term or any term in the sequence equals a1. What is a1? The first term plus n minus 1 times d. And what is d? The common difference, right? So the two things you've got to plug into that formula are a1 and d. Okay, for the formula, a1 and d. There's going to be an n in your equation, in your formula. So you're not plugging in for the n. You're plugging in for the a1, first term, and d. What's that? Okay. So what is the 100th term of the sequence that begins with 6, 11, for arithmetic? So they're telling us it's arithmetic. We don't have to like wonder if it is. We're already told. 6, 11, dot, dot, dot. So it's going to go on forever. We want to know what's the 100th term. Now, what I see in a question like this all the time is that you look and what is the common difference that you could tell just by knowing the first two terms? 5. So you'll write down on the test, you'll like keep adding 100 times 5 to get that last term instead of using the formula. The point is to try to use the formula, not to keep adding 5 100 times. But that always happens. It happens in every class. It happens in pre-calculus. We'll do the same thing. They have the same formulas and they don't do it. So the first step would be we need to make our formula, right? The formula is an equals a1 plus n minus 1 times d. Okay, we're going to plug in for the a1 and the d. What is a1? Right? a1 is the 6, right? And d is 5. So in this formula, you're going to plug in 6 plus n minus 1 times 5. Now that can be simplified. an equals 6 plus 5n minus 5. an equals, this like term, 6 minus 5. So it's 5n plus 1. So that's a formula for any term in the sequence. Now, if I want to find the 100th term, what would I do? Yeah. I started with this, I plugged in A1 and D, and I simplified. Distributive property, combine like terms. Five times n, 5 times -1, right? And then I added 6 minus 5 is 1. So again, once you've got a formula, if you want to find the 100th term or any term, just plug in the subscript, right? Whatever that number of, what I call the ordinal number of the sequence, of that term in the sequence. A100 is 5 times 100 plus 1, which is 501. So without having to add it up on the back of your test 100 times, you calculate it. And usually when they do a problem like that, that's why they're going to make the numbers pretty high, because they don't want you to just keep adding. What's that? Well, we were told find the 100th term and use the formula. I mean, we're going to use the formula. I mean, if the question is, what if all you're asked for is the 100th term? I mean, you could have plugged in the 100 there at that step. You could. A lot of times the question is, find the formula for the nth term and find the 100th term. And if all you do is find the 100th term, then you're not going to get all the credit. Okay, you're going to miss a significant part of it. If it asks for a formula, it means something which is a sub n equals, and there's some expression on the other side that you can use to find any term. Right? So don't just, this one, to be truthful, did not ask for that. It just said find the 100th term. But if it says find the formula, then take that step. That's why I did that. And you can notice, because this is arithmetic, that this an equals 5n plus 1, it's kind of like linear, mx plus b. And that's what arithmetic sequences are. They have if you graphed them, it would be a bunch of dots on a graph, and that would be linear. Okay, so try to do the same thing then with this one. Find the 46th term of a sequence that begins 3, 5, 7. And again, they didn't say it, but find the formula and then plug in 46. No, you have to make that formula. I mean, I can give you this. This is the part which you should have taken as a note already. An equals A1 plus n minus 1 times D. Yeah. Anybody get a number? What'd you get? Actually, 90 what? 91? Anybody else? 93? 93, right? Should have been 93. How many got 93? 91? What did you add? What was your first term? What did you add? The A1. Okay. So let's see. So the first term is 3. What is the common difference? right? D equals 2. So you should have plugged in AN equals 3 plus n minus 1 times 2. And if you wanted at this point, you could have just substituted the 46 and found that term. If you find the formula, we would simplify that. AN equals 3 plus 2n minus 2. AN equals 2n plus 1. Okay, now when we plug in 46, A46, we get 2 times 46 plus 1, which is 93. You know, if you did it up here without having simplified the formula, you would have 46 minus 1, which is 45. 45 times 2 is 90, plus 3, 93. Either way. Okay. So the geometric sequence, this switches to the next section, is the sequence in which the ratio between consecutive terms is constant. In other words, it looks like you keep multiplying by the same number. Right? So arithmetic, you keep adding the same number. Geometric, you keep multiplying the same number. Yes. Please. Good. Gabby? Everybody? So which one of those looks like it's geometric? It looks like you keep multiplying by the same number to get the next term. The second one, right? And again, by the textbook definition, the ratio of consecutive terms is constant. The ratio means divide. 2 divided by 1. 4 divided by 2. 8 divided by 4. You know, every time it's the same thing. It is 2. So the ratio of consecutive terms is constant. You know, because that constant is bigger than 1, the terms keep getting bigger. You could have smaller than 1, and they get smaller. Is the third one geometric? We know it's not arithmetic. We checked it before. Is the third one geometric? I mean, 4 over 1, 9 over 4, not equal. So that's not geometric. So that was the only one in that list which was geometric. Okay. Good. Okay. If it is geometric, if it looks like you keep multiplying by the same number to get the next term, whatever that number is called common ratio. And that we use lowercase letter r. So you're going to get the same kind of questions with this. So is it geometric? If so, what's the common ratio? So does it look like this one is geometric? Does it look like you keep multiplying by the same number to get the next term? Well, test it. 6 over 3, 12 over 6, 24 over 12, 48 over 24. Are they constant? Yeah, it's 2. In every case, it's 2. So what is the common ratio? 2. R equals 2. What is A1? 3, right? This is the A1. What is A4? 24. Oh, you just jumped on that one. So it's still not too hard, right? I mean, the part about identifying arithmetic and geometric is easy. But using the formulas gets it a little more complicated. So do those two. Determine whether they're geometric, and if so, what is R? Are they? We're not using any formula right now. We're just identifying, is it geometric? Oh, pretty boring here, aren't they? Which one is, which one isn't? The B isn't? Yeah. The B is arithmetic, right? We used that one before, so it's not that. But the A, does it look like you keep multiplying by the same number? And that number is 2, right? So 4 over 2, 8 over 4, 16 over 8, which is 2. So R equals 2. A1 is 2. Okay, so just like with arithmetic, for geometric, we have a formula for the nth term of the sequence, right? And that's the formula. Again, you're given the formula. You don't have to remember that. You just have to know how to use it. Right, and an equals a1 times r to the n minus 1. So that there's 3 unknowns on the right, a1, r, and n. You have to plug in for the a1 and the r. In order to have a formula, you need to plug in for the first term and the common ratio. You know, an example formula would look like this. Right? An equals 5 times 2 to the n minus 1. Right? In that formula, what is the a1? 5. And what is the r? 2. Now, the thing you got to keep in mind here, because this is the common mistake if you're given that on a test, is that you try to multiply the 5 times the 2. And you can't do that. Right? These are properties of exponents. The 5 is not being raised to the same power as the 2. So don't try to multiply those two numbers and make it a 10. It won't work. Then the other thing to recognize, and all the formulas are going to look something like that. Remember what we said about the arithmetic? It kind of always looks linear. This one looks exponential. So when you're looking at these formulas, if it has an exponential thing, that's geometric. So find the 10th term of a sequence, 4, 12, 36, and they told us it's geometric, so we don't have to figure it out. So again, I'm going to use this formula. An equals a1 times r to the n minus 1. And I'm going to plug in for the a1 and the r. Okay, what is the A1? Right, there's the A1. And what is R? What does it look like you keep multiplying by to get the next term? 3, right? So R equals 3. So that's all you have to plug in here. AN equals 4 times 3 to the n minus 1. And there's no simplifying to do. Stop, right? Don't try to make it 12. Doesn't work. Okay, now that you've got a formula, how do you find the 10th term? Yeah, if you want A10, then substitute n equals 10. A10 equals 4 times 3 to the 10 minus 1, which is 4 times 3 to the 9th. And that we need a calculator for. Second quit. 4 times 3 hat 9. 778,732. So geometric grows faster than arithmetic, or shrinks faster. You know. I mean, so if you see 10th term, you say, well, it's 3. I'm just going to keep multiplying times 3. I'll multiply that times 3, and I'm just going to do it 10 times until I get to the end. If you know you're going to end up with an answer like that, you could see that it's probably going to be somewhat tedious to do that. It's better, make a formula, plug in for n. And yes, if all it asked was for the 10th term in the sequence, you could have plugged in the 10 right there at that step. But if it asks for the formula, you've got to have that step where you show a formula for an, right? Not that you've already plugged in. So find the 10th term of that sequence. Two, negative 6, 18. What did you say was the value of R? Negative 3. Okay, negative 3. So did anybody get an answer? Say it. Negative 39,366. Okay, so here we go. AN equals the first term of 2 times negative 3 to the n minus 1. That's the formula. And so for A10, it's 2 times negative 3 to the 10 minus 1. A10 equals 2 times negative 3 to the 9th. And that should have been negative 39,366. Okay, find the 15th term. Okay, just using the same sequence, find the 15th term. I mean, you should just be plugging in the same formula, right? Just put in a 15. Did anybody get an answer? I'm looking for an answer. Is that? Not right. Yes. 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 Okay. Uh, okay. Bye. Who got negative 9,565,938? Okay, you're all wrong. You're all wrong. Okay. And here's the thing. If you plug into this formula with 15, right, you're going to get A15 equals 2 times negative 3 to the 14th. When you raise a negative number to an even power, it's positive. But you probably entered in the calculator without the parentheses. So you got to be careful that if you're going to put negative 3 raised to a power, the negative's got to be in the parentheses. If you didn't do it, then the negative, it took 3 to the 14th, and then it just kept the negative, and it made it a negative number. Because in that one, we were doing negative 3 to the 9th. Since it was an odd power, it was going to be negative anyway. That's why I wanted us to do one where when you subtract the 1, it turns into an even. Because that one was a 10, we didn't have the same issue, because raising something to an odd power, it'll be negative. It didn't really matter. But it's good, it's safe to, put in parentheses. If you got a negative, put it in parentheses. Okay. Now, one last thing I'm just going to mention. We're not going to do much with it yet. But there's actually the formulas that we've used so far, which are for arithmetic, AN equals A1 plus N minus 1 times D. AN equals A1 times R to the N minus 1. Right? Those are called explicit formulas, as opposed to recursive. And on the formula sheet, when we get them, they have both of them on there. We don't do much with the recursive, but a little, and they tend to confuse us a lot. The recursive formula for arithmetic is AN plus 1 equals AN plus D. So remember that the subscript here is telling you which term in the sequence you have. So AN plus 1 is the term right after AN. That we're trying to say it in a general way. This could be A4 and A5, A10 and A11. In a general term, AN and AN plus 1. If you want to find the next term in the sequence, then you take the term before it and you add the common difference, which makes sense. We kind of know that. In words, we know that. But in this formula, it tends to cause us some trouble. Right. Same thing for the geometric. If you want to find the next term in the sequence, AN plus 1, you take the term before it, AN, and you multiply it times R. So that can take you from the 10th term to the 11th term, from the 100th term to the 101st term. It's a general way of saying if you want to find the next term, multiply the previous term by R. But most of the time when we're looking for, if it says find a formula for the nth term, they don't want this. We want this stuff right here. This is what you want to use. Okay. So that's the homework.